Hello, welcome to this session. Thank you for staying on. I think this is going to be a very exciting session to listen to. Its name is LTE Broadcast, Multicast for live events and more. My name is Hans Agard. I work at Qualcomm as a product manager for LTE Broadcast. And before we start, I have a few housekeeping issues. First of all, please turn your phones onto silent. And secondly, there will be a Q&A session at the end of the session. And when that comes, please step up to the microphone here in front so we can record it for the video. And that's it for the housekeeping sessions. So I'm very proud to present to you Jack Arkey, who's a principal member of technical staff, product development at Verizon Wireless. We've been working at Qualcomm together with Verizon for several years now to commercialize LTE broadcast technology, and we are getting very close. I'm very excited to hear him today speak to us about it. Thank you.
Thanks. Thanks, Hans. So, as he mentioned, Verizon's been working for quite a while with Qualcomm as our partner and several other vendors to develop this LTE Multicast solution service. And Verizon refers to this technology, which in the standards is known as eMBMS, as LTE Multicast. There are also referred in the industry as LTE Broadcast, and you may have heard it referred to yesterday in the keynote. I know that Qualcomm's been very excited about the fact that we're finally reaching an imminent launch of this technology. And I myself have been working at Verizon on this for 3.5 years, so we're very excited and very proud of the work we've been doing. So this is a very brief update on where we think that Verizon is going to take this technology and where we think the technology is headed. There should be plenty of time for questions. So just want to give you a brief overview of a few of the things that we've started to do with the technology. So as I've been thinking about this technology for a while now, I wanted to share a story with you. When I was growing up in New Jersey, my folks, it was kind of a rite of passage every summer. We'd go to a baseball game. And, we'd take the GW Bridge over to the Bronx and see the Yankees play, or if the Mets were having a good season, we'd go to Shea Stadium. And, as a kid, of course, the pace of a baseball game, your eyes start to wander and you look around and you see the people who are, completely engaged in watching the game, and you see the folks who are buying the concessions and the hot dog and the beer and the popcorn. And then you see the guys, back then anyway, you'd see the guys with the earpiece in their ear, and they've got an AM radio in their hand, and they're listening to a broadcast, right? And they're watching the game, and they're getting commentary as it's going on. That's what we call the enhanced fan experience. And 30 years later, here we are enhancing that fan experience even more. We want to bring those kinds of experiences to the fan, but now it's additional camera angles. Now it's lots of audio tracks. Now it's the ability to play, pause, and rewind and look at that play that you just missed because you were buying the hot dog. So that's the idea in a nutshell behind multicast. And we've seen video grow exponentially across our network, right? We've seen it explode. And we want to be able to keep ahead of that, be able to deliver a high-quality experience, particularly in venue, when you've got lots and lots of folks who want to see the same content. So, in a nutshell, we talk all the time about video, and in a nutshell, multicast enables broadcast video to multiple users. And when we say an unlimited number of users, we mean lots and lots of users. We can reach more people than we've ever been able to before. And that's the real exciting part of this technology. You know, we say, well, we stream today. We stream today over unicast. Yes, you can stream today over unicast. But as more and more people are trying to view the same content, there are all sorts of things that happen in the network that nobody likes, and particularly as a user, you don't like, because you start to see the picture quality degrade, you start to have buffering, you experience all those unpleasant artifacts. And with multicast, those things are not a part of the experience. It's a very high quality experience. So the idea of bringing the experience that is as good as your living room experience to the mobile device is the main aspect of this multicast service. But one thing that I would like to encourage developers to think about is that any type of data can be delivered over this LTE multicast service. And so that opens up a variety of possibilities, and I'm very excited to think about what developers are going to come up with to take advantage of this service, because it's any type of data. We're certainly going to, in the early stages, deal a lot with distribution of video, but there are all sorts of other types of use cases that can be used to distribute data, and I'll go into a few of those and some ideas that we have about where we think the technology can lead. But I do think that there are developers out there I know who are going to innovate with this technology. So a couple of key benefits to talk about. Exceptional quality, kind of hinted at that already. And why is it exceptional quality? It's exceptional because what the multicast service does is carve out a piece of spectrum that is its own, right? Our road is our own. And so what that means is we don't have to do any of the bit rate adaptation that you see today in unicast traffic. So that's the first thing, exceptional quality. That also means best experience. Once you start that broadcast continues. As long as you are in a broadcast area, we'll go into that a little bit in a second, that application is going to continue to run, that video service is going to continue to run unless you walk out of that broadcast service. And of course, it's fully mobile. These are mobile devices, so you can go anywhere with that service. You're not tethered in any way, except for the fact that you are in a service area, in a given service area, when you're using multicast. And it's an effective distribution. One of the things that the carrier in particular likes about this technology is the idea that it is extremely efficient. And why is it extremely efficient? This is the reason. So when describing a traditional, what we call unicast service, this example, we say, say we've got 7 users in a stadium and they're all trying to watch a 1 megabit video program, right? The same video program. So this user has his own 1 megabit copy. This user has his own 1 megabit copy. This user has his own 1 megabit copy. And so what that means is essentially, if we're talking about 7 users, that's 7 megabits of load on the network. That's why you see the artifacts that you do in the traditional unicast model. In multicast, it's a single 1 megabit stream. All of those users can join it. And that's all it takes. It only takes a handful of users for this technology to actually be effective, right? Because 1 megabit is better than 7 megabits. So even in situations where you've only got a handful of folks taking advantage of it, you're already serving the network in an efficient manner. But what is really exciting about this is the unlimited possibility that you can reach more people than you ever have before with this technology. So in the situation, the unicast situation like we described, that becomes unworkable when you're talking about tens of thousands of people. Not the case for multicast. There's an unlimited number of users that you can reach. Another aspect of this service is the fact that it can be targeted. Verizon has done a lot of work at being able to provision these services. We define what are called service areas. And so what that means is that you can deliver this content now to a venue, or you can expand that to a region, or you can do a national broadcast. And it's very highly flexible in that way. You just define a service area and say a certain number of cell sites are going to participate in that broadcast. And so it's effective in being able to target distribution. It's also effective in Verizon's solution because we enable provisioning of the service, which means that you can stand up that service and you can have it last for a given event and take those services down when you're done, return the resources back to the network, makes it highly flexible. We can put up multicast services as we need them and take them down when we don't. So it's a highly effective way to manage our multicast service in that manner. Another aspect, one of the use cases that we've been discussing, and this goes back to the data model that we were talking about earlier, is the fact that you can distribute this data at off-peak hours. So, for example, if you want to do movie distribution, or you want to deliver advertising content, these are the kinds of things, and in all rich media, these are the kinds of things that you could be delivering in an off-peak time period. And so we refer to that as a trickle download, being able to move these large pieces of data in off-peak hours. And then, as we said before, take that service down during the day when we've got a higher peak. So a couple of the success stories. So Verizon has begun to demonstrate how we're going to use this technology commercially. And the first of these was an application that we built around the Super Bowl this year. This is our first public demonstration. And we set up a very large technology tent in Bryant Park in New York City. And this application that you see on the top right demonstrated 5 video channels running concurrently, all in synchronicity. And we were running clips of the previous Super Bowl. During the week, we were running clips of the previous Super Bowl. We were running live NFL Network streaming. We also were showing multiple camera angles on the bottom half of the screen here of the AFC and NFC championship game. And this was just a demonstration of the kinds of things that we think we'll be able to deliver in venue in the upcoming years. Being able to do customized experiences that you're not going to see outside of a venue during a live event. During the actual Super Bowl game itself, we were running the Super Bowl in that top left corner. And again, an example of how regular data can be used as well to push, one-to-many push, to this group of applications that we had in the Verizon tent. So we were getting play-by-play information happening right as the events were happening in the stadium. We were getting player matchups and player statistics that were updating automatically in real time, and Twitter feeds and the like. So again, another example of how you can be pushing live data to these applications using the multicast channel to push data as well as video. Following the Super Bowl, which is a very enormously successful event for us, and a great demonstration of how this technology works, we went to the Indy 500. Verizon has become sponsor of IndyCar this year. And what we did was we took a similar type of application, displaying multiple channels, video channels, and we positioned custom cameras in positions around the track, particularly around the pit row area. And we gave a bunch of Samsung Note 3 devices with Qualcomm multicast chips in them to the drivers' teams, and we allowed the drivers to be able to get this information from their teams about who was driving into pit row, who was leaving the pit row, other things that were going on in the track. We had 8 in-car cameras that were following the drivers as they were driving on the track. And this was a highly successful event for us. We got great feedback from the teams. And it informed us to do a second demonstration of this technology at the Sonoma racetrack just last month. At that one, we were also doing a pit row arrangement, which was great because the track itself was kind of angled like this, so you really couldn't see down the entire pit row. So the teams were able to look at different parts of the pit row from this view, channel view. So it's those. It's those kinds of. Oh wow! Look at that. That's right. Anyway, while they're working on that, that's the kind of enhanced experience that we're talking about in venue, that you can be offering those kinds of camera angles, even when those kinds of things are not available elsewhere. So in addition to that, we enhanced those views. We added more camera angles. We had a camera positioned on turn 11, which at Sonoma is obstructed by a building where the command center is. So it allowed all of the teams to see what was going on that turn. And we're taking all of that experience and we're moving that into our IndyCar commercial consumer application for 2015. And we're really excited about that. We think that this is exactly the kinds of customized experiences that fans want to have. They want to be able to see that and also hear it. We have audio tracks that we're playing of the conversations between the drivers and their teams. We have the command center itself that's talking to the teams during the race and letting them know when there are yellow flags and that kind of thing. All of that stuff is now going to be available to our users who are using the IndyCar application. Anything? So let me think for a second. So from the experiences that we got with IndyCar and building out over the commercial network, all of these applications were done on our commercial network. Now we're taking it to the next level, which is to expand support of multicast throughout our LTE infrastructure. So what does that mean? That means that venues will start to be outfitted with LTE Multicast, and we'll move, just as LTE itself and the evolution of LTE moved from city to city and expanded outwards, we'll do the same with venues. We'll do all of our IndyCar venues, we'll do all of the stadiums, and we'll expand from there into regions and eventually national service. So that's how Verizon plans to deploy the multicast technology. One other thing to note, we haven't spoken yet as developers about what are the new pieces that need to go into supporting multicast. So one, as I already mentioned, there's a chip inside these devices. Qualcomm makes the chip that goes in the, today we've been using the Samsung Note 3, which already has this chip available. In addition to the chip that tunes to the middleware, there is in addition to a chip that tunes to the signals, there's a middleware that has to talk to this chip in order to enable communication between the modem and the middleware. Oh, thank you. Terrific, except they can't see them. Yeah, I'll save this. I'll save this one because I can speak to it later. But I'll speak about the parts that we need right now for to support multicast. So in addition to middleware chip for all video streaming, we're using the MPEG-Dash protocol. This is the protocol that was developed several years ago, and we've seen encoding vendors really start to adopt MPEG-Dash, and we're starting to see a huge support across all of the industry to adopt MPEG-Dash. So in addition to having to encode an MPEG-Dash, of course, that means that you need an MPEG-Dash client and player to decode the MPEG-Dash and display it to the user. So MPEG-Dash, another big part of this solution. Let's see if we're about to get our slides back. Okay. You know what, as long as we're waiting for a couple of these, I'm wondering if maybe we just take some questions while I'm waiting. Sure.
How many different models do you have right now in your network with the multicast feature?
How many different models?
Phones, devices.
Right. So, as I mentioned earlier, Samsung has a Note 3 that is already capable of receiving these multicast signals, and we've upgraded it with middleware in order to show it and demonstrate it at these events. So the first thing we will do is that those devices that do have the capability will certainly look to upgrade those devices so that they can take advantage of the multicast service immediately. And then in 2015, we've got a number of devices that are coming online, early part of 2015, that'll be multicast capable. You know, multicast and the whole evolution of LTE, you're seeing all of these new services that are starting to sprout up and take advantage of the LTE footprint, including voice over LTE with high quality voice calling, and LTE Direct, as I think was mentioned the other day. So this is part of that whole build out of different LTE services on top of the existing LTE infrastructure. And multicast is a really exciting part of this and a big part of how we take advantage of this huge LTE infrastructure. So, yeah, sure.
You consider, Verizon consider to launch for all the country in the near future? Because maybe the examples are for export, for stadium, for massive events. But I don't know if it's a good idea in terms of business, in terms of monetization to do for all the country.
For putting different types of content, you mean into stadiums?
In all the country. For example, to launch maybe one game in order to see in all USA. I don't know if it's a good idea. Maybe San Francisco 49ers is not important for New York.
Oh, I see. In other parts of the country? That's interesting. That's not the impression that we get about the way that fans consume, in terms of football, consume that content. They love to watch other games that are going on. I don't know if are many of you familiar with Red Zone, which is a program that shows the last 20 yards and shows the football players that are about to score a touchdown. So that's a really good use case, actually, of how there are fans in a stadium who might be watching a game in front of them, but they also want to see what's going on in other games across the country. And Red Zone is one way to do that. Very difficult to do that with tens of thousands of fans wanting to watch a Red Zone in a single venue. But with multicast, that's certainly a capability and quite likely to be happening in 2015. So let's see. I've got my slides back. Is this working? Yeah, there we go. Okay, great. So I was talking a little bit earlier about the data delivery and using the data channel. And this is just one of the ideas I wanted to share with you as developers to give you some inspiration as to how this technology could be used in new ways for data delivery. So one of those is the idea of a skinnable app, right? Because you can distribute content to these different service areas, and those service areas can be very targeted. They could be a department store. It could be a theme park. It could be any area. Remove the four walls. It could be a golf course. So the idea being that you could wander into a service area with an application that was skinnable, and all you're doing is just sending little skinnable information to that application using a data channel. It's just one idea that I wanted to share with you to give you an idea of how we might use this delivery service in a different way. So not only have the enhanced fan experience that would already be part of this application, but actually make it dynamic so that it changes depending on where you are. So it goes to, you're at an NBA game, it suddenly becomes an NBA app. Or you go to a BCS game and it's BCS, or it's baseball tonight. So, that's just one idea that I wanted to give you. And you see this bullet point about, complementing Wi-Fi services. So lots of folks do ask, what about Wi-Fi? And there are a couple of things. Wi-Fi is complementary because all of the uplink that you still want to do, your Facebook and your Instagram and all those things, those have to go on somewhere, and those are much better used resources over Wi-Fi. But for delivering video, for example, very difficult to do over Wi-Fi. You don't have the ability to carve out the spectrum like you do in multicast over LTE. You have to put a great deal of forward error correction on that video stream in order to keep its integrity, because you're fighting with all these other resources over Wi-Fi. So we see these as complementary solutions. Wi-Fi is always going to be made use of in stadiums, but we also see this technology as being able to enhance the experience with video delivery. And the final thing I wanted to emphasize on the data front is digital signage. We see enormous possibilities for implementing digital signage solutions. Today, there are older systems using 3G and even 2G. Can't do the types of rich media distribution that advertisers are looking for. There are lots of opportunities because it's mobile where you can do all of the kiosk-based advertising. And in addition, we displayed one type of idea, a prototype, last week at the CTIA event, which is the mobile event. And we showed a prototype, what we call a machine-to-machine adapter, which had an HDMI out and could be plugged into any monitor. And the reason why that's important is this now enables digital signage to be mobile as well. So that if you're setting up for a live concert event in a big field, you could put up signage in that field with something like this dongle solution. And it doesn't require all that laborious infrastructure to enable that signage. And remember that signage is all synchronized. It all occurs together and can be delivered together and can be delivered in real time with very low latency. So just one other solution that I wanted to share with you and the possible use cases for multicast. And finally, while we had our interruption, I've already discussed some of the impacts that you would see as a developer and what you need to be aware of in taking advantage of this service. One other thing that I would leave you with is the fact that content providers and service providers have to also integrate on the back end with Verizon. So we've built into our provisioning service, we've built APIs for content providers to push their content to our broadcast servers and get that to the service areas where they want to deliver their service. So we're very excited about this new technology. We think it's going to enable some enormous innovation, and Qualcomm's been a leading partner in the development of this technology, and we're really excited about it. So thanks very much. So we'll take any questions that you have now. Yeah.
Based upon their interest. Like if they are interested in the games, then you will be showcasing them the game videos, right?
Correct.
So
Yep.
is that like Verizon is sponsoring that data to the customers, or like?
Yes. So one of the things that we want to do is incentivize our customers to use this. As I indicated earlier, this is a highly efficient distribution for this type of video data, specifically video data. So yes, we'd like to see our customers using it. And what that means is we may not use the traditional models that we would for charging for data consumption. It doesn't mean there's not going to be ways that this has to be paid for, obviously. Right. We've put a lot of research and effort into this. But to charge in the traditional data model, we don't think makes sense. Everybody's tuning into the same channel.
So you don't have a model right now. You're not sure exactly how you're going to implement that, but you have
there are a lot of
ideas
business.
on the back
Yeah,
end.
there are a lot of different business plans that are being discussed. So,
right.
Yeah, not ready to share those, but
okay.
Yeah.
Thanks.
Thanks.
So to dig a bit deeper on that, or the other end of the spectrum where you said the content providers can push the content to you. So how do you, as Verizon, schedule inventory? It seems like you're a lot like a broadcaster.
Yeah, exactly. Yeah, so as I said, there are APIs in this provisioning service that we've developed so that we can somewhat remove ourselves from the process and let the content providers who really know how to handle live events and schedule those live events do that and simply pass the messages on to us for the provisioning piece.
And are you monetizing that between you and the content providers, or are they paying Verizon to broadcast?
That's definitely one business plan that's being discussed. Yeah.
Will there be any SDK by which even the independent content providers can also host the content?
Yes, so if you weren't at the keynotes yesterday, Qualcomm announced that they have a middleware SDK for LTE Broadcast. Verizon also has APIs that sit on top of Qualcomm's middleware to enable use of the Verizon solution. So yes, there's an SDK available, and Hans, I believe it's on a website, on Qualcomm's website now, right? Yeah.
And it will be available on all the platform like iOS and Android, or?
Currently the platform is Android only.
Okay. Thank you.
Mm-hmm. Over here.
Can I just ask, is there a roadmap for iOS or other platforms in the future?
Yeah, so that's we get that question a lot, and we don't know what Apple's plans are. They have there's their own group within Verizon that I'm not allowed to speak to, so but we know all of the OEMs are very interested in this technology. They've all been taking a look, all been having discussions. So we expect to see more devices come online in 2015. Over here, yeah.
In-house solution, do you have in mind of the unlicensed LTE?
So there have been a lot of conversations about unlicensed LTE, and I see Hans smiling back there. I think that it's really intriguing, and it's definitely an area we're going to take a strong look at. to see how we can leverage unlicensed LTE to do the same types of services we do over LTE today in our licensed spectrum. So yes, I think there's a possibility there. Yeah.
How many simultaneous sessions it can support, like multiple programming can it support?
Yeah, so it depends on the use case, and it depends on how much spectrum you're going to apply to the multicast service. So the standard actually allows you to take up to 60% of your spectrum for multicast. So that could be a fair number of channels, depending on the bit rate of your video, or if it's smaller data, it could be a lot more in the way of channels. So I think, I wouldn't say that it's unlimited, but depending on the use case, you can have many channels.
Thanks. Yeah.
Mm-hmm.
Yeah, hi. At the keynote yesterday, there was a member from Facebook spoke about using LTE Broadcast for other types of applications, such as application update and such.
Right.
What is Verizon's plans around allowing those types of functionality on the network?
I think the software update is it's so mundane. Like I was saying earlier, the video is the thing we're always focused on, but software updates, especially in Facebook's case, where they're talking about billions of users and so many mobile devices that they have to update, this becomes a very compelling solution. So Verizon's taking a hard look at how we're going to solve distributing software updates in this method, and I think it's just around the corner. Yeah.
Just curious, like from user side, how if there's multiple channel, how did they know like which channel to pick and navigate between them?
Mm-hmm. Yeah. So this is part of the application APIs in communication with the middleware. There is a channel that's always on that is sort of like a service guide. It tells you all the services that might be available in the particular service area. And it communicates with the middleware to tell you, okay, here are the things that are currently available. And then the application can query the middleware to find out what those services are. Mm-hmm. Anything else? Okay. Well, thanks so much. As I said, we're really excited about this technology, and we're looking forward to launching it in 2015.